Today we're going to work on age problems with one variable, and we're going to do one problem with Tyrone and Kari, two people. So let's begin. Okay. In this problem, Tyrone is 2 years younger than Kari. 12 years ago, Kari was twice as old as Tyrone. How old is Tyrone now? Well, in age problems, the first thing I like to do is identify who's younger. And right off the bat, it says Tyrone's 2 years younger than Kari. So I'm going to put a little Y by Tyrone's name. Then I like to make a table. And in the table, I like to have one row for each person that's in the problem and one column for each time period that they talk about in the problem. In this particular one, there's 2 people and 2 time periods. So I also need rows for one row for labels and one column for labels. So I'm going to go ahead and make mine a total of 3 columns and 3 rows to accommodate the titles. All right, let's begin with that. It's a little bit longer here. Okay. And 2 people. Okay, so I'm going to go ahead and label on the left-hand side with the 2 names, Tyrone and Kari. And across the top, what I'm going to put up here is in the first column, now, the word now, so that I know that in this column I'm going to put expressions representing their ages now. And over here, I'm going to label it 12 years ago, because I'll have information for that too. Okay. I'm going to make sure I put it right on the spot here so I don't forget at the very end to go ahead and put the name, because sometimes you get so busy doing all the work and excited when you're done that you forget to really answer the question. All right. I also like to use, I want to use one variable to write both of their ages, and I like to use assign the variable to the younger person. It's my preference. It seems to work better, and that younger person that up here I identified as Tyrone. Put a little Y there just so I don't forget. So for this problem, I'm going to use T for Tyrone's age. And because Kari, according to this problem, is 2 years older, what I need to do to get her age in an expression is T plus 2. I'm going to add 2 years on. Okay. One thing that's always true about age problems is that once you identify who's younger, they're always younger. That will never change. And when you have a different time period like this, 12 years ago, everybody's going to be 12 years younger. And you have to always remember to, if you write a new equation, to subtract 12 from, or whatever the given age adjustment is to everybody. So in this case, I'm going to need to write T minus 12 to represent how old Tyrone was 12 years ago. And for Kari, I'm going to go ahead and put her age now, which is T plus 2 minus 12. Okay, and I know what you're thinking is, well, why don't you just make that T minus 10? Well, I want to show everything for right now, and we can simplify later. So the second sentence says, 12 years ago, Kari was twice as old as Tyrone. Well, here's where basically I'm being given another way to write Kari's age. All right, so another way to write it is that Kari was twice as old as Tyrone. Here's where you got to be really careful, because what you're doing is comparing both of their ages 12 years ago, and you got to be careful about whose age you double, and make sure you're really aware of who's younger. In this case, since Tyrone is younger and Kari is twice as old as he is, the two, where I'm going to double one of their ages to make them equal, needs to go in front of the expression T minus 12 representing Tyrone's age. So what I'm going to do here is go ahead and create an equation. I'm going to double Tyrone's age, T minus 12, and that should make their 2 ages equal according to this word problem. So it's T plus 2 minus 12. And don't worry, I'll get right to simplifying this side. So the T minus 12. T minus 10. Okay, now here we're going to be really careful to make sure and use a distributive property. to solve this problem. Okay, so it's 2 times t minus 2 times 12, or 24. And those two expressions are equal. Now I've got variables on both sides of the equation. I'm going to go ahead and solve this algebraically. I'm going to get rid of one of these terms that's got the t in it, because I only want one of those. And I'll do that by subtracting t from both sides. And that's going to leave me with a positive t over here. 2t minus t is 1t. I'll bring down the minus 24. Over here, these 2, of course, are equal to 0, so we'll bring down nothing. Let's finish at 24. Okay. Equals negative 10. Okay, I'm running out of room, so I'm going to rewrite this up here so I can finish it. T minus 24 equals negative 10. And I'm going to, since I want to isolate t, I will add 24 onto both sides. And that will get my t all alone. Okay. Really, once you get the problem set up correctly, then you just do a little bit of algebra. Okay, so t equals negative 10 plus 24 is 14. Okay. Now what I need to do is go ahead and check all my work, or check my answers. And I like to take my answer and put it back into the table and basically fill in the rest of the table with what I believe, according to my algebra, the answers are. Tyron's 14. Kari's 2 years older than that. That would make her 16 now. All right, now 12 years ago, if Tyron's 14 now, he would have been 2. If Kari's 16 now, 12 years ago, she would have been 4. All right, so I'm going to reread the problem, make sure all of this makes sense. Tyron is 2 years younger than Kari. Okay, yes. 14 is 2 years younger than 16. That's 2 less than 16. 12 years ago, Kari was twice as old as Tyron. Okay, according to this, 12 years ago, Kari was 4 and Tyron was 2. And 4 is twice the number 2. It looks like we do have a correct answer, and it's real important that I go ahead and write this answer right up here. Tyron was 14 years old. Done.